Right, hi folks. In this last tutorial that we had, or lab that we had, I gave some problems as a review for final exam. And here is one that people asked me to make a tutorial segment out of it. Uh, we have a disk shown here, which is turning, and we have an arm, which is that orange object that is also turning simultaneously. And the description of the problem is given here. In other words, you can read it, stop and read it, but the bottom line is that if you looked at this graphically, so the disk is having a constant speed, 15 RPM, for 2 seconds, then it stops at that location, and then after 2 seconds, which means after a total of 4 seconds, it starts to move with a given RPM, 30 RPM. Now, as far as the rod is concerned, or the arm is concerned, the first 2 seconds, it goes at a constant speed, 15 RPM. Then the next 2 seconds, it actually reverses direction, and it goes for another 2 seconds at the same speed. So after 4 seconds, it ends up where it started, which means the zero location, zero angle. And then the last 1 second, it goes at 30 RPM, which is double speed of that. Now we can do problems of this type either by creating these two sketches, and we have choices of either scaling them both in the horizontal and vertical direction, or input it as it is without any scaling involved. Now I've done other tutorials, two blocks racing against each other, and another problem where a block is going down a track at a complicated motion, and you can look at those and review it. But anyway, the first tutorial, the first video segment is going to be doing this problem based on creating sketches, okay? Just like that. All right, so let me go ahead and create the assembly, which is very simple. So insert a new part in there, and then this one I'm going to call the disk. So this is going to be properties. I'm going to call it the disk, and the disk. Okay, let's make it. So on a convenient plane, on that horizontal plane, I will sketch a circle. There's the disk. And why don't I, here, I exit and pad it. These dimensions are not important because I'm not asking for any sensor generation and things like that. So I make it, let's make it 3 this is units, so these are all units of millimeter. Maybe I better change my units here. So tools, we can do that at the end. So on this plane, I will draw a circle. This is where the arm is going to be positioned. Okay, and just, okay, exit and pad it. The arm is going to get mounted on this little thing. I don't know what's the, okay, 3 millimeters. Good. Now, on this side, I will make a little protrusion because otherwise the motion of the disk is not going to be clear when it's turning. So this is going to be another circle, which I'm going to make a pocket. All right, just so that I can see the thing rotating. Now, that's pretty much it. So as far as the disk goes, this is what it is. Then I'm going to insert the rod, I think. Insert a new part in there. I'm going to call it the rod. Properties, rod, and rod. Let's make it. Okay. On that plane, I will sketch. Why don't I project that circle? Because the rod is actually going to be inserted in that little protrusion. So we're going to draw the rest of the rod. Okay, so that's your projection. Then we go to that sketch and complete the rest of it. So something like this. The original orientation is not important because it is irrelevant to the problem. However, since at some point I want to plot some maybe angular position, so let me later on make a point there. Okay, so let's see now. This is 3 millimeters. Good. Change the color of that. Orange. Okay, and make a point while I'm here at the center of this circle. Center. There we are. So at some point I'm going to draw the angular position of this this point. By the way, maybe I should also make a position a point there. So let me go back to the disk. Okay, make a point at the center of this tiny little disk, or okay, let's zoom in. Circle, that circle. Okay, there's my point. All right, very good. Exit. Well, why don't we save everything before losing the data in case there is a crash here? So File, Save Management, Save As. Okay, Save As, Desktop, new folder. I'm going to call that thing April 4. April 4. April 4. Put everything there. Okay, since the first tutorial deals with doing this problem by creating these sketches, I need to make these sketches somber. So what I'm going to do is I will actually insert a dummy part here. So we're going to say insert a new part. It's not new part. Say no. And I'm going to change the name of these things to sketches. The only thing I'm going to have here are those two sketches. So let me see now. What do I want here? Properties, sketches, and sketches. All right, very good. Now, by the way, let me change my units also. So tools, options. So as far as the length goes, I'm going to make it inches, and I think that's pretty much it. Okay, what do we have here? Well, let's go make these sketches now. So double click on sketches, and on a convenient plane, on this plane, I will sketch. You know, actually, I feel better if I did not draw it on these sketches. Let me create two planes here. So a plane offset from this plane, okay, 2 inches. Okay, so one of the sketches I'm going to do on this, and the other one I'm going to do on a different plane. I could have done everything there, so let me make this thing a little bit further back over here. Okay, and then I'm going to make another plane on the other side, just so that I can see a distinction between the two. So insert, a plane, offset from that plane, or maybe we do it here. Okay, so we do it here. That's good. Okay, on one of these, I'm going to make the sketch for the rod, and the other thing the sketch for the disc. Okay, so let's do that. On this first plane, I'll sketch. Okay, something that looks like this. Okay, in earlier tutorials about 2 months ago, I said that you don't really have to put the exact dimensions here. You can make this thing between 0 and 1, and also this between 0 and 1. Okay, and then you scale it later on. Maybe that's what I should do. That's fine. So let me do it like that. So let me see. My first one is going to be like this. I'm going to put the dimensions in a minute, 0 and 1, and then like so. Okay, so let's see. Let's put some dimensions. So from here to here, all the way, it's going to be 0 to 1. So this is going to be, each of these is going to be point, I suppose, this is going to be 0.2. Well, let's see now. Let's see. Dimension from here, from this point to that point. Just a second. This thing went to state of coma. I have to wait for this thing to come back. So the first interval is 2 seconds, then it's 4 seconds, then it's 5 seconds. Okay. All right. So let me do this thing. This dimension, I want it to be horizontal. Can I do that? I guess I'm going to delete this. So let's try it again. Dimension. Where's that? Lost my dimension. Maybe accidentally I closed that. So constraints. Let me see, what was the view, toolbars. Okay, I must have accidentally closed it, and I don't remember what the name of that toolbar was. However, the best way is to reset everything. Customize. Okay, toolbars, restore all contents, and restore all positions. Okay, so let's close the stuff that I don't want. I don't want that. There's my dimension. This one was accidentally closed. All right, good. So let's do it. Dimension from this point. Well, I should have do it like that. From that point to this axis. This is very sensitive, so let's try it again. Dimension from this point to that axis. There. I want this thing to be point. So the entire time interval is. So this will be point. Let me see now. Point. Let me see. From here all the way to the end is 1, and I have. If I divide this thing by 5.2, so this is going to be 0.4. Okay, 0.4, non-dimensionalized. Okay, distance from here to here is going to be 0.8. All right, and the distance from here to there is going to be 1. Okay, good. You move these things out of the way. This goes down. This goes down so I can see it better. Now let me also scale vertically. So distance between this point to that point. We're going to non-dimensionalize this. So this is going to be 1. Ultimately, that 1 means that it's going to be 180. So we have to scale it later. And then distance between this point and that axis is also 1. So the idea is that what I created here, this is for the rods, remember? What I created here is a replicate of this one on the top, except that everything is divided by 5 horizontally and everything is divided by 180 vertically. Okay, good. So exit. And just so that I remember, it's this sketch that I put on, I believe, plane 1 right there. I'm going to call this thing rename properties, and I'm going to call this thing for the rod. This was for the rod, sketch for the rod, okay? I'll actually call it sketch for the rod. Sketch for rod. Okay, good. Just so that we can keep track of what is going on. Then I select the other plane. Right, this one. And I'm going to sketch on it. Now, if these things are bothering me, I can always hide it. Like this is blocking my view, so I'm going to hide this. Right, and do the sketch again. So let me see now. For the disk, it looked like this. Of course, I have to normalize these things. All right. So let's put some dimensions here. From here to here. Again, this is 0.4. And then from here to here, it's going to be 0.8. And finally from, oops, wait a minute, this should be 0.8. 0.8. And from here to that vertical axis is going to be 1, the total time duration. All right, now as far as the scaling goes, from this point to this point, this is going to be 1. And from this point to that point is going to be 0.5. Just look at the this thing. You can see that that's the way it is after you scale it up. Exit. There we are. And I'm going to rename this thing to be the sketch for the disk. Okay. So properties, sketch for the disk. All right. So this one I was hiding. So right there, you can see that. I don't need these things right now. Later on, I'm going to have to pick these because these are basically my my formulas or laws. All right, so let's go here, assemble this. So first thing I'm going to do is anchor the right. I need a revolute joint between this and a base, okay, and I need a revolute joint between the rod and the disc. Now, just so that people, although it's not necessary to create a piece underneath, but I will do that. So let me go insert a new part there. New part. This step is not necessary because you don't really need this thing in order to make it. Where was it? Right here. And I'm going to rename this thing to be the base. So properties, I'll call it the base. And base. Oops. base. Okay, good, good. All right. If you want, you can reorder these things. So let me see if it makes you feel better. I can reorder. It's not necessary. That's okay. We just leave it the way it is. All right. What have we got here? Okay, so oh, we have to make the base. It's just basically a cylinder, a simple cylinder. So on this bottom plane, I'll sketch a little circle there, exit, and pad it in the other direction. See that? This is going to be the base. I don't really need it. Oh, while we're here, let me also change the color of it. I think since I reset my reset my toolbars, the color, the view graphics is lost here, so I have to do it like this. Right click, properties, graphics. I'll just make it green. There. Okay, it's totally unnecessary, but we can do it without that. All right, let's go ahead and fix the base right there, and then make a revolute between the disk and the base. So coincident the axis of the disk and the axis of the base, and between the bottom of that, or the bottom of this disk, and okay, so let me hide this, the top of that. This is going to make a revolute join without an offset later on. Okay, so let's bring it in the front. All right, good. Now let's create a revolute between the rod and the disk. So this axis, I'm going to hide this, and that axis, and coincidence between, let's get the two planes. Let's bring this thing in the front, between this plane and that plane. Both of these are going to become revolute joints later on. Okay, let's not forget to save everything here. All right. Okay, so now we go to digital markup, the MU kinematics. Get the magic wand out. Where's the magic wand? Right there. A new mechanism. Auto create. You're going to have two joints, two revolute joints, 2 degrees of freedom. Okay, right there. Okay, let's make this thing angle driven. We make a 0 to 360 because we want to test this, and the other one also angle driven, 0 to 360. Now remember, we do not need to specify this range. This is only if you want to do manual command. So you can see that is the disk itself, and this is the arm itself. All right, good. Okay, let's create some sensors here. What is this? Speed acceleration sensor. So one of them is going to be, let's see now, the reference product is of course the reference product is, let's see now, what are we doing here? Just 1 second, where are we? Okay, so sensor, the name of it, this one I'm going to call the rod. Reference product is the base, the thing that's stationary, and the point, because this is the rod, I'm going to select this point, and another one, going to call this thing disk, And reference product is once again the base. And the point is going to be the point that I created at the hole of the disk. Okay, good. We have created that. And now we're going to put some commands here. Okay. The commands right now, I made them angle driven myself because I wanted to manually do that. If you go to these commands, okay, if you go to these commands, and if you double click on the first one, notice it says, what do you want to link it to? This first one, if I'm not mistaken, was the, yeah, you can see it's a disk. You can see the disk. So I say link it to the disk, the sketch that I created for the disk. Now, let's go here to sketches. And there's two sketches here, the rod and the disk. This is what I want. It says, what is the time interval? So let's simulate it over 5 seconds, because that's what we want. All right, that's good. I'm going to scale it in a minute. We close that. And you double click on the second one, and once again link it, but this time to the one that was for the rod. And 5 seconds. Okay, good. Now I want to scale these things, because right now the scale is 1. We want to make it 180. 180. Remember, this 180 has no units, but later on it's going to become a degree. And this one also 180. 180. Cancel. This one 180. Okay, so we changed the scale here, and we are pretty much done. So let me go ahead and let's go ahead to our mechanism design. All right, and we have simulation with laws. All right, the total duration is 5 seconds. 5 seconds. Okay, activate our sensors. And what is it that we want to plot? Well, we want to plot the angle. Okay, or you can select these two. Okay, or you can go ahead and select the position, angular position. Okay, as I said, you can go ahead. Let me see now. Angular, these are X, Y, Z coordinates, angular speed. Is there something that's directly angle? I don't see it, so okay, so just select these two. Okay, yes and yes, and then plot it, and then simulate it. I think my scaling is not right, but we'll find out. We'll find out. Okay, so let's plot it, graph it, and see what happened. Graph. Oh no. Oh yeah, look at this. Look at this. It says the shape is okay, but the unit is not correct here. We talk about 3,000, 5,000. So our scaling is not correct. So probably I have to keep it at scale equal to 1. Let me go ahead and change it. So rewind this. Rewind that. And I have a feeling that let's go ahead and change that thing to back to 1. We'll find out. Okay, so back to kinematics, simulation with laws, activate sensor. These are already activated, and total duration of 5 seconds. So let's play it. And graph it. There's a problem with my scaling. We've got to sort it out. Right, you see that? You see? 25 degrees. So the shape is okay, this is okay, but what happened is that this scale, this should be 180. Is that not true? This should be 180, okay? Okay, so let's see now, right now this is 12 and a half. This should be 90. So let's see. This is 25. Okay, so this is 25, and this should be 180. Okay, so let me go and properly scale this. This actually, if you look at the number down below, it says 25.7. Now let's see, 25.7, 180. 180 divided let me get my calculator. 180 divided by 25.7. A scale of 7. Yeah, you have to think about this this scale value to see why is it like that. Well, that's okay. You can do it. So let me close this, rewind. Okay. Let's change the scale to 7. I should have thought about this thing before I made the video. Okay, let's go ahead and do it. Alright, so simulation with laws. Activate sensor. Play it. Okay, graph it. I'm sure this is going to be okay. Right. Yeah. So you see, we are getting the graphs that you were supposed to, and now it's okay. Now it's okay. All right. This is some food for thought for you to find out why that scale should be it's 7. I'm not sure. I may have to go and check my sketches and things like that. But anyway, we're supposed to reproduce these graphs, and we are. Now the second part of the video number 2, is going to be doing the same thing with not formula, but using the C scripting. In other words, creating a rule. You see, it's going to be a lot. This business of scaling and things on that.